These handy tools have become ingrained in the day-to-day world of tower climbers, but it's time for us to understand a clear guideline of how we can and should use them safely. Are you ready to talk quick rigging connectors? Let's go. We all use carabiners when it comes to fall protection and rescue gear. But the bottom line is that these devices are out of scope for the B30 standard for rigging hardware. Unfortunately, there are people out there in the field that are using these improperly and they're paying a high price. That's why it's come time for us to understand the difference between a carabiner and a quick rigging connector, or QRC. I'm here with the SEMC Core Committee member, Richard Cullum. We're here at the University of Dayton Research Institute where the QRC testing is going on. Richard, what do climbers need to know about this effort?
That's a great question, Sean. Basically, we did a surveyed 8 members, and they asked them how many people currently use carabiners in rigging. And 75% of the respondents said they use them for loads typically under 500 pounds.
So what's wrong with using carabiners?
Well, currently, carabiners are primarily used in PPE, and people have adopted their use for rigging. And there's not really a mechanism in place to do it unless you follow 1048. There's a provision in there that allows for standard and non-standard use. Standard would be ASME B30 approved, non-standard would be a QRC.
So what is the difference between a carabiner and a QRC?
A carabiner is used for PPE, and a QRC would be used for material handling and as a non-standard rigging component. Z359 gives provisions on how to mark carabiners for PPE in kilonewtons, and in A1048 they have a working load limit provision. So our riggers understand what a working load limit is.
So kilonewtons are for your harness and working load limit is for your rigging.
Additionally, carabiners are tested as PPE in accordance with Z359. There's not a standard in place for QRCs, and that's what we're here today trying to establish. We're trying to come up with a baseline for testing going forward.
All right, Joey, explain to me what you got going on over here.
We're doing a static load test on a material handling carabiner, quick connecting link, however you want to reference it. And in doing so, we're running a triaxial load.
Okay.
So we're pulling at 120 degrees in 3 different directions. We're going to take it to failure. And in doing so, Jordan's going to pull this till it breaks, and I hope you enjoy it.
Oh, let's see.
It's going to be a lot of fun.
Ready? No. 1,000, 2,000, 3, 4, 5, 6.
Always. Never ready for that. Not ready for it.
Yeah, that gate's done.
Awesome. See, cool. Very, very interesting. So after the beaners are tested, what are you guys doing over here? What are you looking at?
Anything from shearing, gate opening. We'll measure the gate opening against what was originally there. Elongation, deformation, twisting, cracking.
And Richard, what were you measuring?
So I'm looking for the gate opening, right? So if it sprung open, we'll look at the opening, right? We did our pre-measurements, and then we do our post-measurements. And so if there's a difference in that, we measure that. So this is probably pretty well.
That's a good beaner right there. So after you get all this information, Stephanie, what do you do with it?
So I'm taking the data after we've either retired it because we're not going to test it any further, or we've tested it to failure. I'm taking the data and I'm entering that in the spreadsheet. So we'll take the data and we'll figure out what are some of the warnings for users, for the climbers to know what not to do, how they all perform, and then we will have that available probably by Nate to be able to put out and to have a paper for the industry.
Yeah, that's good. This testing is very important. Everyday use. You said in the ANSI A10.48 that there's an allowance for non-standard rigging components.
That's correct. Standard rigging components are ASME B30 approved, right? So there's a standard that clearly defines how they're used and the limitations on the manufacturers understand that. However, it has an allowance for non-standard rigging components that allow a rigger to use non-standard components as long as the manufacturer stamps a working load limit on it or an engineer approves it. However, it could be against a corporate policy of your own company or the company you're working for, who owns a tower site.
So I can use a QRC?
Well, if you asked me that question 6 months ago, I probably would have had a different answer. But since our testing, I'm comfortable as an engineer to use them in the field if it's okay with my company policy, it's in my construction plan, and it's not against my customer's policy.
3, 2, 1.
So Sean, I just want to clarify that, make sure that people do not mistake PPE carabiners for QRCs. You stated it perfectly earlier. Basically, kilonewtons go for your PPE on your harness, working load limit on your rigging.
So what is the goal of all this testing?
We want to help NATE membership, right? 75% of the members admitted to using carabiners in the field. We want to make sure that going forward we have ASME B30 approval, hopefully an interpretation letter this summer, and then ultimately develop our own testing standards and own standard for QRCs. It's really important for us and the industry.
That's all great information, Richard. Thank you.
Thank you, Sean.
And thanks to Nate and the SCMC for all the work that they do. You'll have a peace of mind when you use a QRC that it's been made right and it'll be able to take the forces that you put them through. Thanks for watching and stay safe.